Hello everyone, welcome to RDCS tutorials. In today's lecture, we are going to discuss deadlock, one of the most important topics in operating system. The deadlock is a favorite topic in UGC NET, TG set and other degree examination technical interviews. Okay, before understanding deadlock, think about there is one example traffic jam. Okay, sometimes vehicles become stuck because every vehicle is waiting for the another vehicle to move first. Okay, the nobody moves and the entire road becomes blocked. Similarly, there is a situation can happen inside a computer system. The process may wait for the what? The process may wait for the resources. Okay, the process may wait for the resources held by the other processes. As a result, none of the process can continue. This situation is called a deadlock. Okay. So in this lecture, we will understand what is deadlock, what is resource allocation graph, what are the necessary conditions, and with the real-time examples. Okay. Now moving to the formal definition of the deadlock. Let us begin with the formal definition. Deadlock is what? Deadlock is a situation. Okay. A situation in which two or more processes are unable to proceed because each process is waiting for a resource that is currently held by the another process. Okay. Again, I am telling the definition. There are two processes are there. The two or more processes are there. If you want to they are not unable to proceed the process because each process is waiting for a resource that is currently held by the another process. The important point is that here the process is waiting. Okay, now you need to remember the word waiting. Whenever the process is waiting, the other they don't want to release the resources. The process is in a waiting stage only. So here the process is waiting only. The process is not terminating and the process is not completed. Okay, the process is not terminated and the process is not completed. Then what the process is? The process is in a waiting. So everyone is waiting. The nobody can move forward. The operating system becomes what? The operating system becomes stuck. This endless waiting situation we call as a deadlock. Okay, I will give one real time example. So the person A has a pen, the person B has a notebook. The person A has already a pen, the person A needs what? The person A needs book, notebook. The person B is already a notebook, the person B needs what? The person B needs pen. If neither the persons cannot release their resources, they both will waiting forever. So this we call as a deadlock. Okay. So now the question is why the deadlock is occurs. The deadlock is occurs because resources are limited. The main because the resources are limited. Whenever the resources are limited, the deadlock will occur. So for example, a computer may have only one printer. Okay, here there is one computer is there and there is one printer is there. Okay, just imagine this is a printer. So many processes may need only one. There is multiple processes are there. Many processes are may need the printer. Okay, there are many processes are there. The many process needs what? These many process needs the printer. Then all process compete for the same resource. These all process are wants what? These all process want the same resources. What is that resource? That is a printer. If resources are allocated improperly, the waiting situation can occur. Eventually, the process may start waiting for each another process. When the waiting becomes the circular, the deadlock will occur. Whenever the waiting becomes circular, the deadlock becomes occurs. The more competition for resources, the higher than the chance of a deadlock. Okay. Imagine there is only one ATM machine is there. Okay, there are several customers want to use the ATM machine. So everyone is waits for the access. Then proper management may create the waiting situations. This situation we call as a deadlock. In particular, this type of situations will come a deadlock. Okay. Next one, the process and resource concepts. Before going further, we must understand two important terms. The first term is process. Okay, now we need to remember two terms. The first term is process. The process is what? The process is simply a program that is currently running. Okay, the process is nothing but it is nothing but one program that currently is running. So, for example, the Chrome browser. So, whenever you open the Chrome browser, here the process is running. Yes, Chrome. Yes, Chrome browser or any browser. And if you open MS Word, here the process is running. If you open the PowerPoint, if you open any application in your mobile or laptop, these are processor when it is nothing but their processes are running. Okay. What is the second term? The second term is resource. Okay, resources are things required by the process to complete their work. If you want to complete any process, the resources are required to complete the process. So, example, what are the process? CPU, memory, printer, scanner, and disk space. So, process needs resources. Perform the what? If you want to perform any process, the process needs what? The process needs the resource to complete the particular task. When multiple process requires the same resource, the deadlock becomes possible. Okay. And there is student needs, there is one example is there, the student needs what? The student needs the printer to print the assignment. Here student is nothing but the process, the printer is nothing but the resource. If the student process the printer, sorry, if the student want to process some work, the which one will require? The printer resource will require to complete the assignment. Here assignment is nothing but the task. Okay. The deadlock example. Let us see a simple deadlock example. Process P1 has already a resource one. The process P1 is already a resource R1. Now P1 requests what? The P1 requests the resource read R2 needs or requests. The P1 requests the resource R2 and now P1 requests the resource what? The resource R2. At the same time, the process P2 has resource R2 and the resource is already have from whom? The resource is already has resource R2. Okay. Now P2 requires the resource what? This P2 is requires the resource R1. So here P1 is waiting for what? The P1 is waiting for the resource R2 and the P2 is waiting for the resource P1. P1 is waiting for the P2 and P2 is waiting for the P1. Neither process release its resources, therefore the both processor wait for our this condition situation we called as a deadlock. This is the classic deadlock example used in textbooks and examinations. Okay, and I will give one more real time example also. So here there is one example. Student A has a calculator, student B has a notebook, and student A needs what? Notebook, and student B needs calculator. If any process will release their resource, it will process. If then either they are not releasing their item, the both wait forever. In this situation, the deadlock will occur. Okay. So one more example is there. It is a traffic jam example. Let us understand the deadlock using our real life example. Imagine a busy traffic junction is there. There are four vehicles enter the intersection from four different directions. These are the vehicles from the four different directions. There is a junction is there. These are four vehicles are there. Okay, vehicle. For example, this is vehicle A. Vehicle A waits for what? The vehicle A is wait for vehicle B, and the vehicle B is wait for vehicle C, and vehicle C is wait for the vehicle D, and vehicle D waits for the vehicle A. Are you getting my point? Vehicle A is waiting for vehicle B, and vehicle B is waiting for vehicle C, and vehicle C is waiting for vehicle D, and vehicle D is waiting for a vehicle A. Now every vehicle is waiting for what? Every vehicle is waiting for the another vehicle. There nobody can move, nobody moving. The entire junction becomes what? There is nobody moving, the entire junction will becomes blocked. This situation is exactly similar to the deadlock in a operating system. The process here, the vehicles are nothing but the land, the process behave like vehicles, and the resources behave like the roads, these four junction roads. When everybody waits, the nobody is progresses. Okay, there is one UGC net point example. Deadlock means what? The deadlock means simply the circular waiting plus resource dependency. Okay, the next one, resource allocation graph. Okay, deadlock can be represented graphically using a, if you want to represent the deadlock graphically, we will use what? We will use the resource allocation graph that we call as RAG. Okay. This graph, what is this graph? This graph help us understand the relationship between the process and a resource. Process, the relationship between process and resource. The process are requested using the circle and resources are represented using the rectangles. If a process requests a resource, okay, if the process requests a resource, an arrow is drawn from the process to the resource. Okay, this is a process and this is resource. If the process want to request for a resource, the arrow should be like this. Okay, if a resource is allocated to a process, it is requesting if any resource is allocated to the process, an arrow is drawn from the resource to the process. Using this graph, the operating system can analyze the resource allocation situations. Okay. And one more example, the student requests the printer allocates to the student, it is represented using the arrows. This we call as RAG, resource allocation graph. The next one, the real-time deadlock example. So consider there are two processes are there. Okay, consider process P1 and process P2. The P1 owns what? The process P1 owns resource what? Resource R1. And the request the resource what? It will request the resource R2. And process P2 owns the resource what? R2. And the R2 requests the resource what? P2 is request the R1. When we draw the graph, a cycle will appear. The cycles are extremely important in deadlock analysis. Why the cycle indicates, we will see. Okay. What is the cycle? How the cycle will come? The P1 owns the resource 1, it owns the resource R1 and requires the resource R2, and P2 owns the resource R2 and request for the R1. So this we call as the cycle or forming. The cycle indicates the process are waiting for each other. So in many situations, a cycle, whenever the cycle is forming, it suggests the deadlock. Okay, the exam point of view, cycles in resource allocation graph is an important deadlock indicator. Whenever the cycle is formed in a graph, we immediately identify, okay, this will form the deadlock. Okay. The next one. There are four necessary conditions are there in a deadlock. This is the most important slide in the deadlock chapter. Deadlock cannot occur randomly. Okay, this cannot occur randomly. There are these four conditions must present simultaneously. Even if one condition is missing, the deadlock cannot occur. Okay, even if one condition is missing, the deadlock cannot occur. So what are the four conditions? Mutual exclusion, hold and wait, no preemption, circular wait. Remember this rule carefully. Whenever the deadlock is nothing but all four conditions present together. If one condition is missing, the deadlock cannot occur. Okay, we will see one by one. What is the first one? The first one is mutual exclusion. Okay, mutual exclusion means a resource cannot be shared simultaneously. So once one process can hold only one resources, that one resource cannot be shared simultaneously. If one process work is completed, then only it will share to the another process. It will cannot be shared simultaneously. The resources cannot shared simultaneously. Okay, only one process can access the resource, the other process must in a waiting stage. Many hardware resources are following this rule. Okay, for example, a printer cannot print documents for two users simultaneously. Yes, we request one document from the system to the printer. Two users can print the same time. No, it will not possible. The printer cannot print the documents for two users simultaneously. Therefore, the waiting becomes necessary here. Okay, and one more real time example. There is only one ATM machine is there, that one customer uses on at a time one ATM machine. So other wants to wait. So this is nothing but the mutual exclusion. Okay. I think one more example is that no, hold and wait. Hold and for the mutual exclusion, I will give one more example. Okay, suppose a college has only one printer is there. Okay, a college has only one printer is there. So how many students are there to want to use the printer? Five students are there. Five students want to print some assignments through this one printer. So only one student can print at a time. The remaining students may wait. The waiting occurs because the printer cannot be shared simultaneously. Yes, the printer cannot be shared simultaneously. This we call as a mutual exclusion. Okay, moving to the next one. What is the next condition? Hold and wait. In hold and wait, a process already holds a resource. What is the hold and wait? A process is already holding a resource, and again it the process is wants to another resource. It is giving request to the another resource. Yes, instead of it releasing one resource, it is requesting the another process, another resource. While waiting, it continues holding the original resource. This behavior contributes to the deadlock. Okay. So what is the example here? Process P1 has hold the printer. Now it requests the process P1 is scanner. Instead of releasing the printer, the process P1 is requesting the scanner. So here it is holding and here it is waiting for the scanner. So this is hold and wait. In many process behave similarly, the deadlock becomes possible. Okay. What is the third condition? The third condition is no preemption. So what is the no preemption? If no preemption, once a resource is allocated to one process. Okay. What is that? If once a resource, if once a resource, there is one resource is there. If this one resource is allocated to a one process, is allocated to one process, the operating system cannot be forcibly take it back, cannot be removed forcibly. This process only itself release the resource, otherwise it will wait for the resource. But the operating system cannot be forcibly removed the particular resources. This restriction contributes to the deadlock. Okay. And simple example, there is a library book is there, okay, in your college. Library is there, right? So there is one library book is there. The library book once is issued to the particular student, it remains with the student until the student will return. So this is nothing but the no preemption. And allocate resources. Suppose a student borrows a laptop from the college lab. Okay, borrow from the college lab. There is a laptop. Okay, the lab assistant cannot suddenly take it away while the student is working. While the student is working. Similarly, the operating system usually cannot forcibly remove the allocated resources. Okay. What is the next one? The next condition is circular weight. The circular weight is the fourth and final condition required for the deadlock. In this condition, a set of process forms a circular chain. Okay, in this condition, what is that? The processes can form what? The processes can form the circular chain. Circular chain. Okay, since every process is waiting, the nobody can proceed. Okay, every process is waiting, the nobody can proceed. This creates an endless waiting situation. The circular wait is one of the easiest way to identify the deadlock. Okay, we'll give one real time example. There are four friends are exchanging the notebooks. Okay, the friend A waits for the B, and friend B is wait for the C, and friend C waits for the D, and friend D waits for A. Nobody received the requirement. This we call as a circular. But how it is circular wait? Friend A is waiting for what? He is waiting for the B, and B is waiting for the C, and C is waiting for the D, and again D is waiting for A. This form is circular. So it is nothing but the circular wait condition. Okay. Next one, circular wait. One more example is there. So what is the? Consider there are four processes are there. Okay. How many process? Four process. The P1 waits for a resource held by P2. The P1 is wait for a resource held by P2, and P2 is waits for a resource held by P3, and P3 is waits for a resource held by P4, and again P4 is wait for a resource held by P1. Now a complete cycle is formed. Since every process is waiting, none can continue the execution. This is a classic circular wait situation. There is one exam point of view. The circular wait is mandatory for the deadlock. Without circular wait, the deadlock cannot occur. So why we discussed all four conditions, then why these all four conditions are required? So that is one of the most important concepts in operating system. Deadlock requires all four conditions simultaneous. Suppose we remove any one condition. If we remove mutual exclusion, if resources are shareable, the mutual exclusion disappears. If resources can be forcibly removed, no preemption disappears. If process never hold the resource, the while waiting, the hold and wait will be disappears. Therefore, the deadlock prevention techniques focus on breaking one of these conditions. Okay. So there are some UGC NET important questions are there. What is the first question? Deadlock occurs when the deadlock will occur, the process execute normally, the process wait indefinitely, CPU is idle, memory is full. Whenever the process is waiting indefinitely, then that situation we called as a deadlock. The answer is B. How many conditions are required for a deadlock? We discussed the four conditions. The required conditions for the deadlock is four. What are the four conditions? Just now we discussed what are the four conditions. It is the first one, mutual exclusion and no preemption, hold and wait, and circular wait. These are the four conditions are there. To the next question. Which condition means the resources cannot be forcibly removed? In which condition the resources cannot be removed forcibly? In a no preemption. In a no preemption. The answer is no preemption. Which condition create a cycle among the process? The circular weight will form the cycle chain. Okay. These questions are frequently asked in UGC NET, TG set, and other degree examinations. Focus on understanding the concepts rather than memorizing the answers. Okay, just to focus on the concept. If you memorize the answer, that nothing will useful. So once the concepts are clear, the MCQs becomes very easy. Okay. In today's summary, what we discussed what? We discussed deadlock, the causes of deadlock, resource allocation graph, mutual exclusion, hold and wait, no preemption, circular wait, and UGC net 4 important questions. Okay. In today's lecture, we learned the complete foundation of deadlock. We understood the definition of deadlock, the reason why it occurs, the resource allocation graphs, and the 4 necessary conditions. Remember one thing, the deadlock occurs only when all 4 conditions are present together. This concept is extremely important for UGC NET and TG set. Okay, UGC NET and TG set, this concept is very important. Okay. So thank you for watching this lecture. I hope you understood the concept of deadlock and its necessary condition clearly. In the next lecture, we will discuss deadlock prevention, deadlock avoidance, safe state, unsafe state, and Banker's algorithm. If you found this video helpful, please like, share, comment, and subscribe to RDCS tutorials. Keep learning, keep growing, and all the best for your UGC NET and TG set preparation. Thank you.